Okay, I'm going to show you how to use a wall and a pendulum to measure the acceleration of gravity. Now, I got this pendulum hanging up next to the wall, and I'm going to move it in until the pendulum just barely touches the wall. Okay? Now, I'm going to bring the pendulum back, and I'm going to release it at the same time as I drop a steel ball in my hand. You can see the steel ball in my hand there. And let's see what happens. Okay, it looks like the pendulum hit the wall a little bit before the steel ball hit the floor. So what I want the pendulum to do is hit a little quicker, so I'm going to shorten it a little bit. And let's see what happens now. Okay, first let's get the pendulum so it's just barely touching the wall when it hangs straight. Okay. Let's try that one. Well, it looks like I made a mistake. The first time the pendulum hit the wall first, and then I shortened the pendulum. Was that a smart thing to do? Probably not. Well, let's try lengthening the pendulum a little bit. Okay, we're going to hang that there. Let's try this. That's getting closer. Now, the point is, if I can synchronize the system so that the ball drops to the floor in the same time it takes the pendulum to swing back to the wall, then from the length of the pendulum I can figure out how long it took that ball to get to the floor, because of course that's going to be the same as the time it took the pendulum to swing back to the wall. And the pendulum of course goes through 1/4 of a cycle before the wall interrupts it. So if we know the relationship between the length of the pendulum and the time required for a cycle of the pendulum, we can figure out the time required for the pendulum to get back to the wall, which will be 1/4 of the time of a cycle, and we'll know the time it took the ball to get to the floor. Then if we know the height from which we dropped the ball, we can determine how long it took and how far the ball went, and from that we can determine the acceleration of the ball with a good deal of accuracy.